Hi friends, welcome to History. I hope you guys have had a great week. I'm so excited for our lesson today. We have a special guest who's going to join us. But first, before we start that, I want to do our review of last week. So if you don't already have a pencil and a paper, pause the video and run grab one. And if you do, we're ready to get started. Are you ready for our review? Okay, let me show you our presentation here. Find it. Okay, so right, left, number one, question number one. Put on your thinking caps, turn them all the way up. Here is our review from last week. Question number one. Who did we learn about last week? A long time ago, a whole week. You remember who we learned about? If you think we learned about Plato, write the letter A. If you think we learned about Aristotle, write the letter B. And if you think we learned about Copernicus, write the letter C. A is Plato, B is Aristotle, and C is Copernicus. Okay, you ready for the answer? C, we learned about Nicholas Copernicus. Good job, guys. Let's go on to question number two. Write a 2 on your paper. Before Copernicus, people believed that the Earth was the center of the solar system and that all the planets revolved around it. What is this known as? Okay, if you look over here at my diagram, you see how the Earth is in the middle, and it shows all the other planets going around the Earth. This is how they believed before Copernicus. Do you remember what this was called? This is a tricky question. Okay, here's your choices. Was this called heliocentric? That's letter A. Is this called gravity? Gravity is letter B. Or geocentric? Geocentric is letter C. What was the belief called that the Earth was the center of the solar system and all the planets revolved around it? Are you ready for the answer? C, geocentric. Remember, a long, long time ago, people believed that the Earth was the center and that the sun moved around the Earth. We now know that this isn't true. Copernicus helped us to learn that. This was called geocentric. Good job. Let's move on. All right, Copernicus developed the heliocentric model of the solar system. What does heliocentric mean? Remember, we just talked about geocentric. Now we're going to talk about heliocentric. What does heliocentric mean? Does it mean that gravity keeps us from floating off the ground? That's letter A. Does it mean that the sun is the center of the solar system and all the planets rotate around it? You think that is what it means? Write the letter B, that the sun is in the center and all the planets rotate around the sun. Or do you think it means that each planet has a moon? If you think that each planet has a moon, write the letter C. What does heliocentric mean? It's B, that the sun is the center of the solar system and all of the planets rotate around it. Good job, guys. Copernicus also announced another theory about our Earth. What was it? He had another theory. Did he believe that the Earth was the largest planet? If you think that's what he believed, write the letter A. Or did Copernicus think that the Earth was made of rock? If that was another one of his theories, write the letter B. Or did Copernicus say that the Earth was tilted and that explained why we had seasons? That's the letter C. Okay, guys, my slideshow has this slide twice, so it's going to show you this one again, and then it'll get to our answer. C, Copernicus believed that the Earth was tilted, which explains the different seasons. Good job, guys. Let's move on. Number 4, if the Earth orbits the sun, or moves around the sun, why can't we feel it moving? Remember, the earth is going around the sun. Why can we not feel the earth moving? If you think it's because A, we're moving too slow, write the letter A if you think it's because we're moving so slow. Or if you think it's because we're too small, write the letter B. Or if you think it's because motion is steady and constant, write the letter C. Okay, guys, I'm just going to tell you the answer because I don't have a slide for this one. This slideshow was giving me problems today. The answer is C, because motion is steady and constant. The earth is moving at a very steady and very constant speed. It's not going fast, slow, fast, slow, fast, slow, or start, stop, start, stop. It's moving very steady and very constant, and so is everything on it. We're all moving together. That's why we can't feel it. Good job, you guys. You did amazing at the end of our review. But I got some really cool pictures of our friends. I'm so excited to share them. I love to share pictures of our friends. Are you ready to see them? All right, I have cute Sydney here. Sydney, you look amazing in your tutor ruff. I love it. Great job. Keith, you did an amazing crown and globe theater. I love them. Excellent. All right, kiddos, I love your crowns and your globe theaters. You did great. We've got a perfect prince and princess right there. Good job, you guys. All right, check it out. I love the creativity here. So we've got our crowns, but we have a Mandalorian crown too. Way to be creative. I love it. Flint boys, you look amazing in your crowns. Good job. Oh, girls, I love your globe theaters and your crowns. And I absolutely love how you have used your shotguns as your audience. That is super creative. Good job. Oh, girls, I love your crowns. You've got a crown on just like me there in the background. Great job. All right, you guys ready for our fashion show? Do you remember we talked about the Elizabethan style of fashion? She liked the Tudor ruffs around her neck, big puffy sleeves, lots of gold trim. That was called the Elizabethan fashion. So we decided to have a fashion show of the fashions we like. Here's some of the pictures I got. All right, girls, I love your fashion. I love the Little Mermaid costume. That is beautiful. And I love the flower dress. Perfect for spring. Those are gorgeous fashions, girls. All right, Savannah loves her sequin sweater. It looks very soft, Savannah. I think I would love it too if I had it. And Story loves her shimmer and shine pajamas. I love shimmer and shine. My little girl watches them, so yep, I watch shimmer and shine too. Wesley, my man, you look amazing as Spider-Man. I love it, and that is the perfect Spider-Man pose. Great fashion choice. Millie, oh, Millie looks like she just needs a hug in that beautiful fuzzy sweater, and I love your hat, Millie. Great fashion choice. You guys did amazing. If you still want to send in more fashion pictures, you absolutely can. All right, are you ready to get started on our awesome history lesson? I have a special visitor for us today. Are you ready to meet him? Okay, here he comes. Oh, maybe here he comes. Hello, my friends. My name is Galileo Galilei. Isn't that the coolest name ever? Galileo Galilei. Can you guys say it with me? 1, 2, 3. Galileo Galilei. You can call me Galileo, though. I was born in 1564, almost 500 years ago. I am an astronomer. I love to study space and the universe and the solar system. And I made some pretty amazing discoveries. So my friend Copernicus, he had some pretty cool discoveries too, but his were just thoughts and theories. He wasn't able to prove anything with science. But me, I wanted proof. I wanted to prove my discoveries with science. Well, I had heard about this new invention, amazing, cool invention that would help me study, the sky and the stars. Do you want to know what this invention was called? Does anybody know? Any guesses? I'll show you. I decided to build one for myself. I built myself a telescope. And with my telescope, I was able to look at the stars and to look at the sky and to look at the planets. Do you guys have a telescope? They come much bigger than this one, but they're so cool to have. So with my telescope, I saw the Milky Way galaxy. I saw that the Milky Way galaxy was made up of millions and millions of stars. Some stars were closer and some stars were further away. This proved that they were not in glass spheres like Aristotle had thought, because there were different distances. I was able to prove that with my telescope. I also was able to look at the moon with my telescope. Before me, people thought that the moon was a soft, round ball with no bumps or ridges. But with my trusty telescope, I was able to see that the moon had craters and valleys and mountains. It was so cool. I also was able to see that Mercury and Venus pass through phases just like the moon. This could only happen if they encircled the sun, not the earth. So I further proved Copernicus's theory. My best and greatest achievement, though, is I discovered 4 moons that moved around Jupiter. This proved that everything did not circle the sun. All right, you guys are going to watch a little video about me now. Are you ready for a cool video? Okay, here's a video all about me. Oh, I got to make sure I have the sound on our video. Hang on just a sec. That would not be good if you couldn't hear about me. Sorry, guys. All this technology is getting tough. Give me a second to find the video about me. I'm great with telescopes, not so good with the computer. Here we go. I think I figured it out.
Ah! Please don't sneak up on me. Dear Tim and Moby, who was Galileo? From Yumi. Galileo Galilei was an Italian astronomer and physicist. His discoveries with the new invention of the telescope changed our understanding of the universe. And his experiments in physics overturned beliefs that had been held for thousands of years. He was born in 1564 in Pisa, Italy. At 25, he became a professor of mathematics at the University of Pisa. Galileo had his own ideas about how the universe worked, and he taught theories that contradicted those of Aristotle. Well, back then, pretty much all of physics was based on the ideas of Aristotle, a major Greek philosopher from the 4th century BCE. Aristotle said that heavier objects would fall faster than light ones. Galileo argued that the speed at which objects fell to the ground was constant. But to scientists in Galileo's time, anything that went against Aristotle's ideas was suspect. That university didn't renew Galileo's contract, so he moved on to teach at the University of Padua, near Venice. In 1609, after hearing stories about the invention of a telescope in Holland, Galileo built one of his own and turned it toward the stars. In early 1610, he published his findings in a book called The Starry Messenger. He reported that there were mountains and valleys on the moon, that 4 moons revolved around the planet Jupiter, and that the Milky Way is made up of individual stars. Yeah, well, Jupiter has way more than 4 moons, but Galileo's telescope just wasn't very strong. These were huge findings, though, and Galileo was appointed as court mathematician at Florence. A few years later, in a paper on sunspots, Galileo wrote that he supported Copernicus's theory of the solar system. Nicholas Copernicus was a Polish astronomer who believed that the Earth and other planets revolved around the Sun. This contradicted Aristotle, who believed everything revolved around the Earth. Not to mention the Catholic Church, which also put the Earth at the center of the universe. When Galileo wrote a pro-Copernicus work called Dialogue on the Two Chief World Systems, the Church took action. Galileo stood trial in Rome in 1633, where a court forced him to say that Copernicus was wrong. They also confined him to his own house for the rest of his life, and the sentence against him was read publicly at every Italian university. While under house arrest, Galileo wrote another major work on the motion of objects, which would later influence Isaac Newton's theory of gravity. Of course, after Galileo's death, most of his ideas were proven correct, including his support of Copernicus's solar system. But Galileo's biggest contribution to science may have been his reliance on the scientific method instead of on abstract theory. He used observations and experiments instead of philosophy and thought. In doing this, he was able to get a more accurate picture of the world than folks who just believed what they wanted to. Hey, let me see what you're looking at. Huh. There's something kind of weird about that.
Aren't I a cool person? I want to prove something to you guys. Remember, I like to prove things by science. I didn't like to just guess. Do you remember in the video when it said everything fell at the same speed? Well, I believe that if I hiked all the way up to the very top of the Leaning Tower of Pisa, because I was born in Pisa, don't confuse it with pizza, but I believe that if I took an elephant in one hand and a ping pong ball in the other hand and I dropped them, they would land at the same time. Should we try it? Does anybody have an elephant I can borrow? Nobody? Nobody has an elephant I can borrow? All right, I'm gonna have to go find something else to use. Okay, I'll be back. I'm gonna go find something so we can try an experiment. Okay guys, Galileo had to run. He said his beard was getting itchy, something about shaving it. So anyway, I'm gonna conduct this experiment for Galileo, okay? I'm gonna have to back up a little bit. I'm gonna talk loud. I hope you guys can hear me. Maybe turn your speaker up on your the volume on your speakers up if you need to, okay? So I'm gonna back up over here. Okay guys, remember, Galileo, he liked to prove scientifically things that happened. He wanted to drop the elephant and the ping pong ball off the Leaning Tower of Pisa, right? I don't know if he really wanted to drop an elephant and a ping pong ball, but he did think that if he did drop two objects of different weights from a way high, from up high, that they would hit at the same time, they would hit the ground. So we're gonna try. I have here an apple. I mean, it's not heavy, but it's heavier, right? And I have a little foam block. If I hold both of these in my hands, this one is way heavier. Which one do you think is going to hit the ground first? The heavier apple or the lighter foam block? Let's try it and see. What's really important though is that I drop them at the same time. Okay, here we go. Did you guys see which one hit first? Was it the apple? Was it the foam block? Let's try it again, just to make sure. Are you ready? I think my foam block hit a little bit sooner that time, but it was probably because I dropped it a little bit earlier. Let's try it one more time. Do you guys see that they hit it almost exactly the same time? If it's not the exact same time, it's just because maybe my fingers didn't open up right at the same time, or that maybe one was up a little bit higher than the other. But they hit at the same time, pretty close. That's pretty cool, isn't it? Let's try something else though. Let's prove Galileo's theory. So I'm gonna take a piece of paper and my foam block, and I'm gonna drop them at the same time. Do you think they're gonna hit at the same time? Galileo says they will. Let's try. They hit at the same time, pretty close. Let's try it this way now. Do you think they're gonna hit at the same time? Let's try it. What happened? Okay, hang on. When I hold the paper this way, it doesn't hit at the same time as my phone block. Let's try it one more time. Maybe I did something wrong. Ready? What's happening, guys? Galileo says that they should hit at the same time. They're not. My piece of paper, it's not following the right rules. I have an idea. Let's try something, because I think maybe the wind resistance or the resistance of the air is catching on our paper. Do you think that's what it could be? I know a way to stop that just a little bit. Let's crumple up our paper. Let's see if this helps. We got it to work. So when our paper was all the way open, there was too much resistance from the air, made it float. But when we took away so much space for that resistance, it fell at the same speed as my block. All right, guys. Oh, let's get me in there. Galileo was pretty amazing, right? I want you guys to do a few experiments. I want you to go around with mom and dad's permission, always with mom and dad's permission, and find a few objects. Maybe you could have a ladder or a chair that mom or dad will help you use. If you have a ladder, that would be really cool. Set it up and drop some things off the top. If you drop some things, something heavy and something light, and see if they hit at the same time, if mom and dad will videotape you and send that to me, I would love to include it in next week's lesson. Let's see some of the creative things that we can drop. But please make sure you have permission to do it, and please make sure that you do it safely. Okay, guys, I have a really cool project for you today. So, question, what did Galileo make? Remember, he made something of his own. Did you say telescope? You're right, he made his own telescope. So you guys, I would like you to make your own telescope too. Now I'm gonna show you my homemade telescope. My telescope is not cooperating. All right, here we go. You see my telescope, and I can close it up, and I can pull it out. So I made my telescope with 3 toilet paper tubes. You don't have to use toilet paper tubes though. You can just use construction paper or cardstock to create your tubes. I'm gonna include the link in this lesson to how to make this telescope. I would love for you guys to send me pictures of your telescopes. I used washi tape on mine, but you can put lots of stickers on it. Decorate it up any way you want, just like Galileo. It probably won't show you clear to the moons of Jupiter, but it's fun to look through, right? Okay, guys, that was a fun lesson. Thank you so much for joining me today. Don't forget to send me pictures of your telescopes if you make them, and I would love to get videos or even pictures of what you're dropping. Just like Galileo, prove. We use science to prove our theories, right? And so when you drop 2 things and you watch them hit at the same time, you're proving that. Good job, you guys. It was good seeing you again. I'll see you later. Bye.